Hello, this will be section 1.1. Once I get there. And that was the wrong place to go. Here we go. So this is just an introduction, a few terms and such. We're looking at 1.1, just an intro to stats. So this is what we do in this class. We'll start like the first third of the class really preparing and doing stuff and analyzing. And then later on, we'll start doing some much more robust statistical tests, and we'll make conclusions from them. So really what I want you to do is be able to write good conclusions, because really we're using statistics as evidence, really, either for or against an argument. I'll look at this a little more in detail later on, but it's prepare, analyze, and conclude. I'll let you read all of this on your own. We collect data. So I'm sure you walked out of a grocery store and someone's got a survey for you. Or even on campus, there's always people wanting to take surveys because they're looking to collect data that they can then do statistics on. So this is it. We get data, we analyze it, we interpret it, we draw conclusions based on it. That's what our science is. So what we're really trying to do is, if you think of fish in a lake, that's my population. So here's a lake, and I got a bunch of fish in it. Well, there's no way I can get all the fish and make measurements from every one of them. So it's really hard to make measurements from every subject in a population. So that's where statistics comes in. It's hard to do a census, so we do samples. So we take a sample, then we perform some analysis, we do statistics on the sample, and then hopefully we get some kind of inference about our population. Like maybe we're trying to see how long the fish were in the lake, what their length was. Well, we'll take a sample, we'll catch some of them, do the statistics, and then make an inference or some kind of conjecture about all of the fish in the lake. So let's just look at an example that goes through all of these. Here we've got pleasure boats and manatees, sea lions. If you look at the table, you can see we've got all these boats and all these fatalities of manatee. And it's hard to look at the table the way it is, but we're trying to see, is there a relationship or a correlation between the number of pleasure boats and the manatee fatalities? Because you can imagine the more pleasure boats, the more than that are running over the poor sea lions. Well, what we always want to do when we're presented data, we look at the source, and here, okay, yep, they look to be reputable. Sampling methods, we'll learn more about sampling, but there's good sampling and bad sampling. This looks like it's reliable, so we're okay to go. And now, this is part of preparing and analyzing. We made a graph because the table was really hard to read. And this would be called a scatter plot, which unfortunately we don't have that time to do in this course, especially in the summer. And if we put a line of best fit in here, it looks like as the boats increase, the manatee deaths increase. So it appears to be a correlation here. It looks like as the boats increase, the number of boats, the manatee deaths also increase. But be very careful. Correlation does not imply causation. We cannot say that the boats are causing all the deaths. It's just that there's a relationship. As the number of boats increase, the manatee deaths increase. So that was part of our analysis. We looked at it, kind of came to a conclusion. We had a graph. We didn't really do much statistical methods other than I drew a regression line in there, a line of best fit, so we could look at it better. And we made some conclusions. We said that there's a correlation between the increase in boats and the number of manatee deaths, but not causation. So let's look at statistical significance versus practical significance. So if you look here, stuff happening at less than 5%, we're going to call that statistically significant. So if you got 98 girls and 100 random births, that's statistically significant because it doesn't seem it's happening by chance, because we know they should be about 50 girls and 50 boys. So if you got 52 girls, well, that's not far from 50, so it's not statistically significant. Sometimes things are statistically significant, but not of practical significance. So here's my example. Suppose we got these 20 stat students. They're spending 30 hours a week for 6 weeks watching videos from Fred University. And their exam scores increased on average 4 points. So when compared to students who did not watch the videos, it was statistically significant. Now, do the results have practical significance? I would say no, because there are other ways to study where you may do even better. Let's face it, 30 hours a week of watching videos just to increase your exam scores by 4 points, not very practical. Let's quickly run through some of these. You can read about them. This is a biggie. When people report data instead of you, the statistician, measuring it, think of asking people about their weight. Well, some people are hesitant to actually give their true weight, so they may lie to you. A better way is if you actually weighed them. Surveys can have loaded questions. Absolutely, I bet you've seen some. The order of questions on a survey can actually be leading as well. Sometimes people will report statistics and they won't talk about the people who didn't respond, because some people like to volunteer information, others do not. That's bias in the sample. Or I should say bias in the data. And be careful of percentages. A lot of people say, oh, there's 100% of these students don't like stats, but maybe they only surveyed 3 students. You always want to give the number, the sample size, which is n, because then people can relate to the n, the number of people, to the percent. If you just give the percent, it sounds like, oh, no one likes statistics, but only 3 students were surveyed. And that's this section. Sorry, this is always the hardest part, is to get back so I can stop the recording.